Hi, welcome back to Mrs. Thompson's classroom. Today we're going to be talking about secant and cosecant functions. We're going to continue our unit on graphing our trig functions. So let's get started by looking at the basics of the secant function. We want to remember, first of all, that secant is 1 over cosine. So let's just think about 0 degrees for a minute. Cosine at 0 is 1. So that means secant of 0 is 1 over 1, which is still 1. So at 0 degrees, I'm going to plot a point at 1. Okay? At pi halves, or 90 degrees, cosine is 0. That means secant of pi halves will be 1 over 0, which is undefined. Now, we know from studies on rational functions that this means there is an vertical asymptote at pi halves. So I'm going to mark pi halves and put a vertical asymptote. Okay, so let's keep working our way around the circle. At pi, cosine is -1, which means secant is 1 over -1, which is -1. So at pi, I'll plot a point at -1. And then down here at the bottom of the circle, at 3 pi halves, cosine, again, is 0, which means secant will be undefined. And I'll have another vertical asymptote. And then at 2 pi, I'll get back to 1. Okay, now let's think for just a minute what the cosine function looked like. The cosine function would have taken these dots, gone through 0, connected to the next dot, and back up through 0. Okay? So let's think about what the reciprocals are doing. So let's try pi thirds or pi sixths for a minute. Cosine of pi sixths is square root of 3 over 2. So secant of pi sixths is 2 over the square root of 3. So instead of this point here, I'm going to have a point here, the reciprocal of it. Doing pi thirds actually gets us a little clearer picture. So cosine of pi thirds is a half. So secant at pi thirds will be 2. Okay, so at pi thirds, instead of a half, I'll have a value at 2. So what the secant function is doing as the reciprocal of cosine is, instead of the curve coming down and being trapped between 1 and -1, it's actually going up away from 1. So instead of getting smaller, it's getting larger. On the negative side, it's doing the same thing. Instead of going back towards the axis, the reciprocals are going to go away from the axis. Okay. And so we're going to continue to have these asymptotes, and we will just continue to have these almost look like parabolas, but they're trapped between these asymptotes. Okay. Now, this right here from 0 to 2 pi is 1 cycle. I have to get the full top part and the full bottom part. So our period is 2 pi, just like sine and cosine. Our range is everything greater than 1 or equal to, or less than -1. Okay, and our domain is x not equal to all of the pi halves. where k is an odd integer. Okay, it has no zeros. It never crosses the x-axis unless I add something and move it up or down. And its asymptotes are at all those k pi halves. Okay, so let's take a look at how we might do this. So we know from before that this pi thirds is our phase shift. And because it's minus pi thirds, this is going to go to the right. Okay, we know that the period is 2 pi. Okay, there's a 1 in front of this x, so the period is not changing. Okay, our a value is 1. So that means what this tells me now is it's not the amplitude of a wave, but it tells me my minimum and maximum are going to be at 1 and negative 1. So that's what I'm going to mark on the y-axis. Okay, and I'm going to start at pi thirds to the right. And we remember that secant of 0 is 1. So my start for all these graphs is going to be at 0, 1, or in particular, my phase shift, comma, a. Okay, so I'm going to plot a point right here. Okay, then we find our end by taking the phase shift plus the period. Now, what basically we're doing 1/3 plus 2. So I need a common denominator. So I'm going to make the 2 6/3. So that makes 7/3. So this is going to be 7 pi thirds. Okay, basically I'm going to go from this pi thirds a distance of 6 tick marks. 1, 2, 3, 4, 5, 6, and plot another point. And this actually does end up as 7 pi thirds. So this is 2 pi, and this is pi. Okay, now the midpoint, the mid is going to be pi thirds plus 7 pi thirds divided by 2, which is 7 pi 6. So if I come in between here, excuse me, that's 8. Haha. And so that's 4 pi thirds. So that's going to be right here. And the mid is going to be basically secant of pi, which is negative 1. So my mid is going to be at pi negative 1, or in general, the phase shift plus the period plus half of the period, comma, negative a. Okay, and so I'm going to go down here. Now, halfway in between those, what we might deem as our quarter points is where the asymptote goes. So I find halfway between 1 and 4 would be 2.5. So actually that's at a 6, and it would actually be 1, 2, 3, 4. It would be at 5, 6. And so I'm going to go up towards that asymptote, and I'm going to go down towards that asymptote. And then I go 1.5 and mark my next asymptote. And I go down towards it and up towards it. And so this is one full cycle. Now to complete the graph, I'm going to continue this up. I'm going to go 1.5 and mark an asymptote on this side so that I can finish here. And then I'm going to go the 1.5 to mark my bottom and 1.5 to make an asymptote. And now I have 2 full cycles. Okay? All right, one of the things you can do on these is graph the cosine first and then flip your secant. So let's try one more. Actually, we're going to go and do this one here. Okay, so in this case, my A is still 1. Okay, my period is now 2 pi thirds. And my phase shift is pi fifths to the right. Now keep in mind this 3 is already divided out. That's why the pi fifths is our phase shift. Okay, now in order to do this problem, I need these to have a common denominator. So the period at 2 pi thirds is actually going to be 10 fifteenths. And the phase shift at pi fifths is actually going to be 3 fifteenths. Okay, so I'm going to do every other tick mark. As a 15th. So 1, 2, 3 of those is my phase shift, and that's where I start at 1. Okay, now my end is going to be 10 plus 3, which will get me to 13 fifteenths. So let's count over. This is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And that will also be up at a 1. Now halfway in between that, so half of the period is so my mid, another way to find the mid is to take your phase shift plus half the period. So that's going to be 3 fifteenths plus 5 fifteenths, which will put me at 8 fifteenths. So if this is 3, 4, 5, 6, 7, 8. And that'll be my valley. And so if this was a cosine function, it would look like this. Now let's find those zeros precisely. I want to go halfway in between here. So it would be right here would be a 0. And right here, halfway in between. Okay, now if that would be my cosine function. So to find my secant function, I'm going to take those zeros and make them asymptotes. And since they're between the tick marks, they would actually be at a 30th instead of a 15th. And wherever I see this valley, I'm going to flip it over. And wherever I see the peak, I'm going to flip it over. And now I have one cycle. Okay, now I can find my next cycle. Well, remember, the period was 10. So from this top point here, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and mark a dot. I'm going to go half of that, so 1, 2, 3, 4, 5, and go to a valley. Okay, and halfway in between there is another asymptote. And this one happens to be at pi 30ths. Okay, and halfway in between here, okay, is another asymptote. And we can flip this down, and we can flip this up, making sure to finish this one. And now I have actually 2.5 cycles of that secant drawn. Okay, so you can do it on its own, or you can draw the cosine first and then mark the asymptotes and flip it over, whichever way works. But the process is exactly the same. We find our period, we find our phase shift, we mark our start, we mark our end, and we mark our mid. So the process for all of these is the same. Okay, now this one is slightly different. So the A is still 1. But now I need to divide this 2 out. So pi fourths divided by 2 makes pi eighths. So now this is my phase shift. And it's pi eighths to the left. Okay, so I'll mark this negative pi eighths. Okay, and this makes my period 2 pi over 2, which is pi, so I'll write that as 8/8. Okay, so our start point is at A, which in this case is 1, which means my end part, so if I count over 1, 2, 3, 4, 5, 6, 7, 8, and so that's actually at 7. I get another top. And then the mid, so that's my end. So my end is going to be at 7/8, 1. My mid is going to be at the negative pi eighths plus half of the period. So that's negative pi eighths plus 4/8, which will put me at 3/8. So this is my mid here, and it will be a valley. Halfway in between those, the quarter points are going to be an asymptote. Halfway between -1 and 3 is going to be a +1. So this is at pi eighths. And then halfway between 3 and 7 is at 5. And that will be an asymptote. And then I can mark down and up. Okay, and this one's going to go up. Now, how far apart are the asymptotes? They're 4 tick marks. So I can go over 1, 2, 3, 4, which will allow me to finish this one. And then I go 1, 2, 3, 4. And if this one right here is up, the one beside it will be down. Okay, now the other thing that you can do here, of course, is we can change A. It just changes what this marking is, and this would be -A, okay? So we can change where that minimum maximums are depending on what A is. The other thing we can do is, of course, add or subtract a vertical shift. And by doing that, all we do is we take this point and we would move it up or down. So we would have to move this one up by my vertical shift. And this one would get moved up by my vertical shift, or down if it's a minus. So I can graph the secant and then move it up or down. Okay? All right, so next time we'll look at cosecant, and hopefully this is helping. Hopefully you'll get some practice. I do have some practice problems here if you want to pause the video and try those. But otherwise, I will see you next time. Thanks so much for joining us.